All too often, when developing applications, developers are hyper-focused on delivering the needed functionality of an application when everything goes right. However, it's just as important to ensure that applications can gracefully handle issues should they arise. Hi, I'm Kyle Burke with MuleSoft's Customer Success Strategy and Architecture team, and in today's Friends of Max video, I'm going to be talking to you about error handling in MuleSoft so that when those errors do happen in your applications, you're able to handle them with ease. Let's jump right in and take a look at how error handling works within MuleSoft applications. Today we will discuss many different aspects of error handling. We will begin with some error handling basics, as well as examples of those error handling scopes. Next, we will discuss error handling at different levels of your application, and finally wrap with how to handle specific errors within your applications. Let's begin by getting a basic understanding of how errors are handled in MuleSoft and what the different error handling scopes are. One of the first things that is important to understand is what exactly is an error in MuleSoft and what are the different components within it. When an error occurs, an error object is created. Each error object has several different components. Note that not all of the error components are listed here, but for the purpose of this presentation, we really only care about two components: the description and the type. The error description is just as it states, a description of the error that's created and what the problem is. The type is a categorization of the error that helps the error handler determine how to route this specific error. Now that we know what an error is, it's important to understand the basic strategy for handling messaging errors that occur within a Mule flow. The first couple steps are typical processing in MuleSoft, as if no error has occurred and everything is processing as normal. Once an error occurs, the first important thing to note is that the processing of the rest of the current scope is halted and the execution scope transfers to the error handler. Once the error handler takes over, the processing of the flow contained within the error scope takes place, and finally a message is returned to the requesting flow. The type of message, either success or failure, depends on the type of error handler that is processing the error. As previously mentioned, the type of response returned by the error handler depends on the type of error handler that is used. In MuleSoft, there are two basic types of error handlers: on-error propagate and on-error continue. The important thing to remember about the differences between the two types of error handlers is to remember that the on-error propagate scope returns an error message, while the on-error continue scope returns a success message. Another way to think about this is in terms of colors. On-error propagate has an error message coming in and an error message going out. Read in, read out. Conversely, on-error continue has an error message coming in and a success message coming out. Read in, green out. If you take nothing else away from this presentation, remember that on-error propagate is read in, read out. On-error continue is read in, green out. Now that we have a basic understanding of the types of error handlers in MuleSoft, let's take a look at how they work in practice with some examples. In order to demonstrate the ability of a flow to handle errors, I built a very simple flow that will intentionally throw an error. The flow is initiated with an HTTP listener, and then first sets the payload to the string of success started flow. Next, there's a validator processor, which will check whether the payload is a number or not. And finally, there's a set payload, which will set the payload to a string of success finish flow. Obviously, as the payload is initially set to a string, an error will be thrown at the validator processor, and the execution scope will transfer to the error handler. In this case, the error handler is an on-error propagate scope, and within the scope, there's a set payload that will set the payload to the string of error main flow. For the first example, we will use the exact flow shown in the previous slide. Firstly, the flow starts off fine, and the payload is set to success started flow, and then goes to validate whether the payload is a number or not. Obviously, since the payload is set to a string, it is not a number, and therefore the validator will fail. At this point, it is important to note a couple different things. Firstly, the execution of the flow stops. aka the final set payload will not be executed. Nextly, it's important to note that an error object is then created, which will have a description component set to payload is not a valid integer value, and the error type will be set to validation invalid number. Now that the error object has been created, the onErrorPropagate scope takes over and the setPayload processor is executed, and the payload is then set to error main flow. Here's where things may get a little tricky. Because the onErrorPropagate returns an error, remember, read in, read out, the original error object description is then returned to the requester, in this case the HTTP listener, and therefore the final body of the response is payload is not a valid integer value. The next example is the exact same flow as the previous slide, except the error is handled with an onErrorContinue scope. Note that everything is exactly the same until you get to step 3. Here, because we have an onErrorContinue scope, red in, green out, a success message is passed back. In this case, because the payload of error main flow in the error handling scope is set, that message is passed back to the original requester, in this case the HTTP listener, with an HTTP status code of 200. Now that we have a basic understanding of the different error handling scopes in MuleSoft, let's discuss what happens when you don't define a flow-level error handling scope. There are two different types of error handlers at the application level: a global error handler and the Mule default error handler. The global error handler is a manually defined error handling scope that will handle errors when there is no flow-level error handling scope defined, and can be customizable with either of the different error handling scopes. The Mule default error handler is the last line of defense when it comes to error handlers. When no other error handler can handle an error, the Mule default error handler will take over the error handling and propagate the error up to the requester. Here's an example of the use of the Mule default error handler. As you can see, we use the same example as before, but this time, we simply don't define an error handling scope. As mentioned before, when no error handling scope is defined, the error is handled by the Mule default error handler, which simply propagates the error. This action is very similar to that of an onErrorPropagate scope with no processor defined in it. Therefore, the error object description is returned to the HTTP listener with an HTTP status code of 500. Here, you can see what happens when you define a global error handler for your application. Note that we still don't have an error handler defined at the flow level, but this time we have a global error handler defined, and hence the error will be handled by the global error handler, which, in this case, contains an onErrorPropagate. Remember, read in, read out. Therefore, the error description will be sent back to the HTTP listener. If you wanted to send back a success message, you could simply replace the onErrorPropagate with an onErrorContinue, and that would allow you to pass back the error global error handler message back up to with an HTTP status code of 200. Thus far, we have discussed how to handle errors when only one flow is involved. But what happens when an error occurs in a child flow and the error is passed from one flow to the other? Let's explore this a little bit further. Here we have two flows where the child flow is called from the main flow via a flow reference. The application, at its core, is the same that we've been working with all throughout the rest of the presentation, except this time the validator is in the child flow instead of in the main flow. First, let's take a look at an example where we have an onErrorContinue scope in the child flow to handle the error. In this case, the main flow is able to successfully call the flow reference, which sends the execution scope to the child flow. In the child flow, an error object will then be created by the isNumber validator, and as such, the execution of the current execution scope will stop. In this case, that means that the set payload in the child flow will not be executed. Since the error object has now been created, the execution scope shifts to the on-error continue scope. The payload is set to error subflow, and then, because an on-error continue is read in green out, the execution scope returns to the main flow as if the child flow completed successfully. This is an important point to note, because an on-error continue returns a success message. For all intents and purposes, the main flow believes the child flow completed successfully, and therefore the final set payload of the main flow will complete successfully, and the payload will be set to success finish main flow. And this will then be passed back to the HTTP listener with a status code of 200. Now that we have seen what happens when there is an on-error continue in the child flow, let's see what happens when we replace that with an on-error propagate. This one is a bit more complex, so it may take reviewing a couple times to fully understand this. Firstly, to level set, the application is exactly the same as the previous example, except the on-error continue is now replaced with an on-error propagate. In this case, the isNumber validator will fail, and therefore the set payload in the child flow will not execute, just as we had in the previous example. Also, the set payload in the on-error propagate will execute, except this time, the error object will be passed to the requesting flow, in this case the main flow. The reason for this is that we now have an on-error propagate, which is read in, read out. Because the main flow receives a message that the flow reference failed, the current execution scope, in this case the main flow, will be halted, and therefore the final set payload will not be executed, and a new error object will be created with the same error description as before. Payload is not a valid integer value. In this case, the main flow does not have an error handling scope defined, and for the purposes of this example, also does not have a global error handler defined. Therefore, the error is handled by the Mule default error handler, which will propagate the error to the HTTP listener and send it the error description of payload is not a valid integer value, with an HTTP status code of 500. Thus far, we have discussed how to handle errors at both the application level as well as the flow level, but MuleSoft also allows you to handle errors at the individual processor level. Let's explore this a bit further. The concept of processor-level error handling is very similar to that of many other programming languages that utilize the try-catch method for attempting to process certain components and handling the errors that occur without completely disrupting the entire application or flow. In MuleSoft, this is referred to as a try-scope. Essentially, the flow attempts to process certain processors defined within the try-scope and handles any errors that occur with the error handling scopes defined within the try-scope. The scope of the error handling within the try-scope is confined to just that of the try-scope and nothing further. If everything in the try-scope is successful, the execution returns to the main flow. In this example, we have pulled out the isNumber validator into the try-scope, and we will see how the error is handled in the next slide. As you can see, the initial set payload is successful, and the execution scope moves to the try-scope. In the try-scope, the isNumber validator fails, just as before, and because the execution scope is confined to the try-scope, the set payload in the try-scope is not executed, and the on-error continue scope contained within the try-scope handles the error and sets the payload to error try-scope. Because the error handling scope in the try-scope is an on-error continue, remember red in, green out, a success message is passed back to the parent flow as if the try-scope was executed successfully, and therefore moves on to the next set payload where the payload is set to success finish flow. This payload is then passed back to the HTTP listener in the body of the request with an HTTP status code of 200. Now let's see what happens when the on-error continue is replaced with an on-error propagate scope. Just as before, the initial set payload is executed, and the execution scope is transferred to the try-scope, and the isNumber validator fails. As before, the set payload in the try-scope is not executed due to the error, and the error is then handled by the onErrorPropagate scope. In the onErrorPropagate scope, the payload is set to error try scope, and then, because the onErrorPropagate is read in, read out, an error message is passed to the parent flow, and another error object is created with the same error. In this case, the main flow does not have an error handler defined, and for the purposes of this example, also does not have a global error handler defined. Therefore, the error is handled by the Mule default error handler, which will propagate the error to the HTTP listener and set the error description to payload is not a valid integer value, and send an HTTP status code of 500. Oftentimes in applications, different errors need to be handled in different ways. Because of this, MuleSoft allows you to specify different error handling scopes for different types of errors. The concept of handling specific errors is fairly straightforward. However, there are certain nuances to it within your application. Let's explore how this works. As we discussed at the beginning of this presentation, one of the important components of an error object is the error type. The error type is used by the error handlers to help categorize the errors and determine how to handle them. All of the errors are classified within MuleSoft within a hierarchy, and the type of any is the parent of all errors that can be handled. When you define an error handling scope for your application, you have the ability to modify the configuration properties for that scope. Within the configuration settings, there's a location where you can specify the type and/or criteria for multiple types of errors this scope should handle. By default, this scope is set to any, aka the parent of all errors, and will therefore catch all errors. However, it can be configured to catch specific error types or utilize DataWeave to match certain criteria within an error object to determine a range of errors that the scope should handle. As mentioned before, there are certain nuances to handling specific errors, and those nuances are associated with which error handling scope will handle the error object that is created. So how do you determine which error scope handles the error? The first question to ask is whether or not there's an error handling scope defined at the flow level where the error object is created. If no error handling scope is defined for the flow, the global error handler will handle the error if it is defined. And if not, the Mule default error handler will handle the error. This is pretty straightforward. Where things get a little bit more nuanced is when there are multiple error handling scopes are defined for a single flow. If an error handler is defined for the flow, the error will be handled by the first scope whose condition evaluates to true. The order of the scopes is determined from top to bottom as defined in the error handling section of the flow. This next part is important. If none of the scope's conditions evaluate to true, the error will be handled by the Mule default error handler, even if there is a global error handler defined. The Mule default error handler will still handle the error. In this example, we have defined 3 different error handling scopes. One for if the maximum streaming size is reached, one for an invalid number, and one for an expression error. For our example, the validation invalid number scope is the one that will evaluate to true and handle the isNumber validation error. One final note is that in this example, we use all onErrorContinue scopes, but this is not a requirement. You can use any combination of onErrorContinue or onErrorPropagate scopes. By now, this example should be very familiar. The only difference is that there are now multiple error handling scopes defined, and the flow needs to evaluate, from top to bottom, which error handling scope will handle the error. First, the flow checks to see if the error type is stream maximum size exceeded, which it isn't. Next, the flow checks to see if the error type is validation invalid number, which it is. Therefore, this error handling scope handles that specific error. Note that nothing beyond the matching scope will be evaluated. Once a scope matches as true, the flow stops looking for a matching error scope. In this example, we simply have removed the validation invalid number scope from the previous error handling example. So now, none of the scopes match the error thrown by the isNumber validator. You will also notice that we have defined a global error handler for this application, but you will see that it is never actually called. Because none of the error scopes match the error type defined by the isNumber validator, the Mule default error handler will handle this error. As such, this error is simply propagated to the HTTP listener with the error description of payload is not a valid integer value, and the HTTP status code will be 500. One other thing to note is that it's always a best practice to put an error handling scope to catch of type any at the bottom of your error handling section, as this will catch any errors and prevent you from going to the Mule default error handler in case an error is uncaught in your particular flow. I hope that you all found this video helpful and now better understand how MuleSoft handle errors when they occur within your applications. If you'd like to find more details on error handling, be sure to check out our documentation site, docs.mulesoft.com, or check out the series of blogs that I put together on this very topic. I've included the link in the description below. Until next time, happy error handling and best of luck in all of your MuleSoft endeavors.